This bell work was rather lengthy, but it does cover a lot of material, and I think it'll serve as a good review. Hopefully you did well on it. Let's take a look at question number 1. On question number 1, it says, what is the degree of this function? And we notice that the tails are both pointing down, so that makes it an even function. So number 1 is even. If you look at problem number 2, it says, what is the maximum of this graph? Well, the maximum is going to be the maximum is going to be the highest y value. And technically, Quizzes has this wrong because if you notice that the right tail goes up forever. So there is no maximum for this graph, and Quizzes says that it's 2. Well, if you look at the points that are marked, we can see that the point on the left side, right at -3, 2, that is the highest value we have marked on the graph. So the problem should have read something like this. If you look at the 4 points that are marked on the graph, what would be the maximum? The maximum would be 2. So we have to be very careful. Sometimes even teachers, when they make these things up, are not very clear. I did not make this problem up. I actually integrated this problem in to make a point. If you look at problem number 3, what is the minimum? Well, it's the same thing. If you look at the tail on the left, it tells me that this graph technically goes forever, and therefore there is no minimum value. However, if you look at the points that are marked, the lowest point on the graph, the y value is -3. So -3 is the lowest marked point on this graph. Number 4. On what interval does the graph increase? Well, let me draw this. I hope you can see it. But notice that this graph is actually increasing between this point here up to this point here. And now that I have highlighted that, I'm going to bring this graph up and make it somewhat larger. We can tell that as x goes from -1 to x is equal to +1, the graph is actually increasing. And that would be highlighted in green there. Number 5. This graph is a 3rd degree, a 6th degree, an even function, or a 5th degree. Well, we know it cannot be even because the end tails, right, point in different directions. The tail on the left is pointing down. The tail on the right is pointing up. So that is not an even function. In fact, it's odd. But this one happens to be a 5th degree polynomial because watch what happens as I trace it and count. As I trace it, right, I can go up 1, 2, 3, 4, 5. So that makes it a 5th degree polynomial. Number 6. If we look at this one, the question is, where is this, on what intervals is this function increasing? Well, this function is increasing on 2 intervals. It's increasing on the left side, and then also it's increasing on the far right side. And I'm going to trace this, and hopefully you can see it. Notice that we're increasing here, right, as we're going up to that top hump. And then if we start at this lower right hump, we will increase forever, right? So the first interval of increase is going to be from 0 to -2. And then it increases again as x goes from 2 to x is infinity. And number 7, this graph is doing what in the highlighted areas? Well, if you look at the highlighted areas, remember we always read graphs from left to right. So if as you're coming in on the left side, you can see that it's increasing. And then if you look at the blue that's not highlighted, it's decreasing for a while. And then when it hits that second highlighted area, the graph begins to increase again. So in the highlighted areas, the graph is indeed increasing. Okay, if you look at problem number 4, it wants to describe the point where y is 4. If you look where y is 4, that is an absolute maximum. This graph does not go on forever because notice we don't have arrows on the end, right? We have points, and that lets me know as the reader that this graph actually stops when x is equal to -2 and x is equal to +2. And if you look at the graph on that closed domain, you can see that 1, 4 is as high as it goes. So that would be the absolute maximum. And if you look at number 9, this graph does go on forever, right? It doesn't have any solid dots. We will assume that therefore it goes on forever. And if you look at that dot, it's not an absolute minimum because we know the graph does go lower on the far left side, but it is a local minimum. It's a local minimum value. Number 10 wants to know where are the zeros of the function? Well, the zeros occur wherever the graph crosses the x-axis. So it appears to be crossing at, I wish this were not transparent, but anyway, it crosses the x-axis at -3, when x is -1, when x is 2, and when x is a little bigger than 5. This is actually not a great graph, but anyway, the best answer choices are -3, -1, 2, and 5. Question number 11. Describe the end behavior on this graph. Well, it looks to me that as x gets closer to -infinity, y gets closer to -infinity, and as x gets closer to +infinity, y approaches +infinity. And let me try to draw this one out for you. We've got, as x gets smaller, notice that y is forever going down, right? And then as x gets larger, y is forever going up. Therefore, the answer is going to be this one here. Problem number 12, what is the equation in factored form? Well, if we look at this, we have zeros when x is equal to -1, when x is equal to -4, when x is equal to +2, and x is equal to +4. So let's think about that. If we have a 0 at 4, then x minus 4 has to be a factor. Well, all of these have x minus 4. In fact, we noticed that when x is equal to 2, we have a 0, so x minus 2 is a factor. And I can now rule out one of these, right? If x minus 2 has to be a factor, well, this can't be the answer. This one doesn't have x minus 2. Let's keep going. Let's go back to the graph and see if we can eliminate anything else. We have a 0 when x is -1. If -1 is a 0, then x plus 1 would have to be a factor. And I know that this one here does not have an x plus 1. So by default, just using what knowledge I have there, I have able to figure out, since it's multiple choice, what the answer is. And notice that we have if I go back to the graph, notice that the multiplicity of the graph at x is -1, notice it bounces at -1, which means it has an even multiplicity, and that's why there's a power of 2 on the x plus 1 factor.